Be1500 Final Project: An Analysis of Traffic Fatalities in 2015. And Nick Sandrock. According to the IIHS, over 30,000 fatal car accidents occur each year. These crashes can be caused by any number of conditions. Our project seeks to analyze the data of fatal accidents from 2015, provided by the National Highway Traffic Safety Administration, determine the greatest contributing factors to these accidents, and inform the users in an effort to prevent fatal accidents in the future. We have done this by analyzing over 80,000 sets of data to create a base of information for our code to reference. We then selected variables that are relevant to a real-world scenario, can be changed by a driver, and are informative. For example, age, location, mental state of the driver, type of vehicle, and restraint use. We then prompt the user for information on their driving conditions, and the code will display to them their chance of being in a fatal accident and information on what the leading factors in fatal accidents are. The code is comprised of 8 function files in total. 6 of these functions analyze the data from the NHTSA to create a reference base. One function prompts the user to input data on driving conditions, and one function that, with a single command, calls the other 7 functions to run and output their data in a concise manner. proj3main is the main function and calls for the other 7 functions to run with one command. proj3input displays to the user input prompts for age, restraint use, and region. It then tells the user what the code will do while the 6 functions run. Here we see the 6 variables and their respective function files. proj3age acquires data on accidents per age group, then determines the chance of the user being in a fatal accident based on their input age. proj3region determines the number of accidents per state and tells the user what chance of being in a fatal accident they have. proj3urb-rural tells the user whether more accidents occur in urban or rural locations based on the data. proj3modyar tells the user what model year of vehicles have the greatest chance of being in an accident. proj3drowdist analyzes the data to determine whether driving drowsy or distracted is a greater contributor to fatal accidents. proj3rest tells the user their chance of being in an accident based on their seatbelt use. Running the code is quite simple. First, one must have all 8 function files and the 3 Excel files in their working MATLAB directory. Then one simply calls proj3main and inputs the information for the prompts and waits for the code to run. I will now run the code in MATLAB, initiating it by typing in proj3main. It asks me for my age as a numerical value. I input 19. It asks me if I'm wearing a seatbelt, and to input this answer as a string, I will put yes. And it asks me what state I live in as a string again. It now tells me this code will tell you your likelihood of getting into an accident based on your age, seatbelt use, and the state you live in. It'll also show you graphs comparing the reasons for different fatal accidents in 2015. So it tells me it's comparing distracted and drowsy fatal accidents, and it says drowsy driving is more dangerous than distracted driving. If you are tired, please do not drive. And it tells me it is now comparing seatbelt use. And it says that if you're wearing a seatbelt, you have a 60% chance of getting into a fatal accident. Now we wait for the different function files to finish running. The code is comparing accidents between different regions in the United States. If you live in Michigan, you have a 14% chance of getting into a fatal accident. And the most accidents in 2015 occurred in rural areas. Most accidents happen in model years from 2000 to 2010. And finally, in age groups, your age group is the 7th at most at risk of getting into an accident based on your age. Please drive carefully. And now the graphs. We have drowsy versus distracted driving accidents. We have seatbelt use. We have seatbelts. We have the state locations, accidents per rural and urban region, accidents per model year of car, and accidents per driver age ranges. Now you can see that there are a lot more accidents for seatbelt use than there are not for seatbelt use. And that is because more people wear seatbelts than not. And same for age of driver. There are many more drivers between the ages of 54 and 64 than there are between the ages of 60 and 20, when you would expect there to be more accidents.